Shenzhen, China's economic experiment. Some people call this the Silicon Valley of manufacturing. It's the rainy season, meaning a lot of rain and a lot of heat, but that did not stop us from seeing one of the largest machine shops I've ever seen in my life, the Deepcool factory. While their factory is here in Shenzhen, their corporate office is in Beijing. We'll take you there right after we check out this massive machine shop.
We're at Deepcool and some serious work happens here. I know you guys have seen some of the videos from factories. Usually you see stuff like PCB, facilities where everything's clean and they're installing components. This ain't that. This is some real work in here. Now what's happening is raw materials are coming in, raw copper, aluminum, plastic, and that sort of thing. And then they're taking those raw materials and they're doing everything here. The first thing is molds. They have to make the molds and they have to make the stamps. And they've got all the equipment here to do it. So they're cutting all of that and getting it ready to make the new products. Now, if you want to make a heatsink for your CPU, the first thing you're going to need are some copper heat pipes. They start off with the raw copper and they make it into the pipes and then they cut it. After that, they arrange it, bend it, and get it ready for the different molds and the different stamps that they've made. They line it up, they get the different fins into place, which is actually just one long piece of sheet metal. Their molds then stamp the sheet metal, get it ready, the heat pipes are inserted, and then each heat pipe is precision stamped into its exact spot.
Okay, so after we got all of the aluminum spins put in place on the heatsink itself, it's then handed off to somebody where the copper piping and the base of the heatsink is then lapped down to a nice mirrored finish to where then it can be additionally stamped with some heatsink grease and shipped out to packaging, where then it gets out to you. Aside from just the heat sinks, we've also got the fans themselves. The fan blades, the housing, all of that is actually fabricated right here in-house. They go through an entire machining process to create the molds that are then done with an injection mold. They've got the plastic comes in here, it's all raw, gets then fed into the machine, and we watched them make a few while we were standing there. They mold them right then, gets handed off to the assembly line, where it's then added into the fan housing itself, and everything's put together and comes. It's a really long, drawn-out process. It's pretty awesome.
We're going to show you how to make a fan. This is the X-Fan 120, a 120 millimeter fan, and the process is going to be kind of typical for any fan that you have out there in the world. So let's make one of these. There's a few different ways to wind the copper to make the magnetic coils. This is one way where they just wind it on, and beside that there's a station where they actually stitch the copper on it. It's sort of a different method. It's like inside versus outside. Two different ways to do it. They use the stitching method when they're doing 6 coils. That's pretty much the only way to do it. They use the winding method when they're doing 4 coils. Things are getting a little bit hot over here. They're actually tinning the tips. There's a wave solder station right here. So they've got plenty of the magnets. They dip them in the tin. The tips get tinned and then they can solder other components to them. Without that, not gonna work. Here we're attaching the coils to PCB. PCB is one of the only things that's not manufactured in-house. You'll notice lots of safety stuff going on here. We've got the mask, of course. But this tube here, it sucks all of the fumes out, so they're not breathing that in. And then, of course, there's an anti-static wristband on each employee, making sure everything stays nice and safe. More fun stuff, LEDs, any color you want. They're just soldering some LEDs directly onto the back of the PCB right now. And then again, this step is going to be optional depending on whether or not you get a unit with LEDs. The testing process. So what she's doing is she's got just a few leads, and she's touching them to the PCB and making sure that all the lights come on. If the lights do not come on for some reason, maybe the solder didn't stick all the way or something, she put them here, and then right behind her, we have someone who can go in and fix any problems that we may have with the LEDs. Right here we have 4 people that are soldering on the power. So they're soldering, the power cord or whatever, the power cable, I suppose it would be. And then there's 3-pin and 4-pin. These are all PWM fans, so they're soldering 4 individual wires onto each PCB. So now we're grabbing a plastic housing and taking everything that's been made so far and sort of threading it in so that it sits in the correct spot in the housing. Pretty meticulous and difficult work, requires a bit of finesse and just a lot of bending and moving things around, moving all these wires into place, putting everything into the grooves and the slots. Quite a decent amount of work going on right here. Here we have something really important. It's not going to spin without this. So she's going to apply some oil, and then it moves down the conveyor belt. He grabs it and applies a bearing right in the center. So the bearing is nicely oiled. Once the bearing goes through here, it comes on back. Here's where the fan blades are applied. The housing and everything is ready. We have a metal ring that goes on the inside as well. And this presses it into place. Now what's happening is we're putting some more oil into the bearing. And once that's in there, once the bearing is finished preparing, we can put the fan, or the blades I suppose, into the housing, and we're good to go. Here's another very important step. This is quality control. Now inside here, they're testing the fan for noise. It's a soundproof room, or as close as you can get. And the main thing they're listening for is any irregularity. It's not necessarily, checking to see how quiet it is or anything like that. If it's too loud, then obviously something's wrong with it. But waveforms show up on the screen, and if they see an irregularity in the waveform, or if they hear an irregularity, then they know something is wrong with the fan. And every single fan that comes through gets tested in this room. As if all that other testing wasn't enough, they're going to test them again. Now that everything is together, they plugged them in there and tested the sound. Now they're going to plug them in one more time, make sure all the lights come on, make sure the fan spins, and they're going to do it, this is basically the PWM test. They're going to do it at 30%, and then they're going to do it at 90%. And make sure that everything works perfectly before they box them all up to go to a different facility where they're going to put the graphics and logos and stickers and all that sort of thing on them, put them in a package, and send them to you. This is the room where they're stress testing me. These things are pumping out heat at 50 C. That's hotter than my CPU runs, and I've got an 8-core. Now right here we have lots of fans hanging here, and they're baking in this heat, and they're just running all day to stress test. This is way too hot. Let's go.
So this big piece of equipment behind me here is actually measuring, it's manually used to measure the distance and the arrangement of the holes in this piece, this industrial cooler that's sitting back here. This thing is accurate down to a single micron. So it's measuring the diameter of the holes, it's measuring the distance between each hole itself and the next, and it gives the entire dimensions of the piece itself. And it's because this has to be that accurate before it can be used in a machine, probably dissimilar to this one here. This is where the technician checks the schematics of the industrial cooler against the actual measurements that she pulled off of this piece of equipment just moments ago.
The heart of China, Beijing. We came here to check out their corporate office and also take in some of the local culture. The people and culture behind the company can sometimes be just as important as the products that the company makes. We came here to learn more about both.
Real plants, someone's taking care of these things. It makes me happy.
A lot goes on in the Beijing office. Marketing, sales, R&D, pretty much everything that's not covered in the factory is covered here in the Beijing office.
Hi, Edison. Talk to us about the design philosophy that goes into your product.
The product team consists of the young engineers and ID designers. We think an excellent product should be special featured and reasonably the design. It's a DIY originated.
I like what you guys are doing in the ITX field. What else can we expect from Deepcool?
So in the future, we will make a lot of different design with the case, with the ITX case, give the gamer the more specially designed. That's our mind.
A lot of people in America don't really know much about Deepcool, but they've been here for a while. How big are you in China?
Deepcool was founded in 1996. We have 20 years cooling experience. We are leading PC component brand in China.
So you guys are the leading brand here now.
Yeah. And we think we can be good in USA and in the world. Thank you.
Deepcool does a lot of R&D in this office, but they also do quality assurance here as well as Shenzhen. Deepcool puts their power supplies through some really rigorous tests here. They spend a lot of time and money making sure that everything works correctly and that it can handle all the loads under lots of stress. And they also do a few other things.
Okay, so you get a little bit of an echo in this room, which is kind of doesn't really work when you're trying to test how loud like a case fan and whatnot is. So they've built this silent room that has got a nice little dampened airlock and oh, these doors are even heavy. Once you step inside here, you can actually hear the complete difference in sound levels. I mean, this is it's stopping my voice from bouncing back at me, and it's kind of messing my head up right now. But at least the door is open, so it's all good. So this is a soundproof room. It's a full-on sound dampening. All of these things are your sound dampening panels, and they're everywhere. This whole entire room is this. We have one light in here. There's nothing else in here, and the light is probably making the most noise aside from me. And they have it for testing the sound decibel levels of fans. So they got like a fan in here that was plugged in and it was making noise. And that's all it is. It's here for testing sound. Looks like they're gonna open the door behind us.
Okay.
Yeah.
It's very silent.
No, it is. Yeah. We just made a little video of how quiet it is.
So we're here with Haibo, and he's responsible for designing a lot of these cases. So let's talk about the Tri-Stellar that you worked on.
3个独立风道的箱体设计是我们 Tri-Stellar 的工业设计灵魂之处。我们把 PC 最热的3个硬件分别放在了3个不同的空间里边，比如CPU 在这边，显卡在这边，然后这边呢是我们的电源，这样呢形成了3个不同的独立的风道。这样的话，有效地缓解了我们硬件因为过热而老化的问题。在外观的设计上，我们赋予了 Tri-Stellar 极具的一个科技感的一个使命。它的设计灵感主要来源于宇宙空间站的一个感觉。把它放在桌面上的时候，能够让我们的顾客的桌面没那么的枯燥，也没那么乏味。每一个我们能看到的部件都是我们在造型与工艺上的一个完美的结合。为了打造这款 Tri-Stellar， 我们在工艺和结构包括外观上没有半点妥协。比如我说一些细节，我们中间这个位置，它既承载了3个不同箱体的一个空间，而且呢，它还是一个开关的按键。这种细节体现在我们 Tri-Stellar 的上面的每个部分。Tri-Stellar is the future.
This was one of our first factory tours, and it was amazing that Deepcool gave us complete access to their facilities. I didn't feel like they were keeping anything secret, and I really appreciate that, so I do want to say thanks to Deepcool. Let us know what you guys thought of the video, and let us know what you would like in future factory tour videos.
And I forgot my hip waders.